So Bharat Kris, BK as he likes to be called, is the executive chairman of the Bharco Ecotechnologies and the Bharco group, and they do business in all over the world, especially North America, Europe, Asia. They are stationed in Bangalore, and they work in areas of environmental health, renewable energy and clean water sectors, and he has a very long standing experience, and as you will come to know that he is very active. And just while talking, he mentioned that they are going to receive the Green Tech Award.
Correct.
Yeah, so great, sir. Now the floor is yours, and please go ahead with your talk. Thank you, sir.
Thank you, Dr. Chaudhary. Well, it's certainly a pleasure to be here at the U.S. Consulate-OSU Waste Management Innovation Conference. I welcome you all. Wasn't that a great session yesterday? Did you all enjoy it? Some very thought-provoking areas, and I think when we talk about municipal waste, especially in the second half of the day, there were some very poignant comments, questions, perhaps suggestions as well. So I'm looking forward to presenting a couple of options to you and to introduce the two speakers today that will be following me for this session on waste management, municipal waste management and wastewater. First of all, I think that the most important thing to say today is there is no such thing as waste. Rishi? Yeah, you can switch on the presentation here. What we'd like to do is we have about 45 minutes Melissa, what time is this supposedly over? The program says one thing. I think we're half an hour off. Is that correct?
Yes.
So we have till 10:45. So we'll have about 15 to 20 minutes per person. We're going to have a question and answer followed at the end. I think there'll be a lot of questions that we need to look at. It was working fine. Huh? Oh, okay. Well, you're the expert. So while we're having some technical issues here, let me tell you a joke. No, I'm the lousy joke teller. But this morning, who was looking at the Times of India this morning? Anybody view the Times of India? What was on the second page? Inside. Did anybody, maybe second or third page, I didn't know which page it was. But it was photos of garbage in various sectors of Mumbai. Now, I'm not picking on Mumbai because every major city of India, every major secondary city of India, class 2 city, and in fact every village of India has got some form of waste management issue. And the reason for that, I think, is that it's called progress. It's called progress. We have waste problems because we have progress. 100 years ago, there was no such thing as landfills. In fact, there was no such thing as waste. Our motto at Bharco Ecotechnologies, waste, no waste. Are we up and running? Okay, super. Waste, no waste. Because, you know, what we did in the old days was that we had a banana peel, we put it in a compost. We made manure out of it and we put it in our gardens or our potted plants or whatever. Our grandparents or our great-grandparents never wasted clothes. We didn't throw them away, we didn't put them in the dustbin. We made rugs out of them or we made rags out of them. And by the time that they were finished, they were so disintegrated, they were biodegraded anyway, right? But now we have a new way of thinking called landfills. It's about 100 years old now. And as long as we have a behavioral thinking that if we give our banana peel to a dustbin, and that dustbin goes to our maid, and from our maid goes to the municipal corporation worker, and the municipal corporation worker takes it to a transfer station, and so on and so forth, it's out of sight, it's out of mind. We've given it to a municipal process, and we've forgotten about the basics of repurposing of waste. So in my discussion this morning, I'm going to talk about centralized solutions and decentralized solutions for waste management. With over 100,000 tons a day of garbage being produced in the urban cities alone, and another 7 lakh villages on top of that of India, you have a lot of waste. Yesterday, one of the esteemed speakers took a piece of paper and threw it on the ground and said that was waste. I thought that was extremely important to understand the significance and the symbolism of that. If one person does it, it's there, we can go and we can pick it up, and it is not a problem. If, in growing up in Western Canada, we had about 200,000 people, or 2 lakh population. If 2 lakh people did that, it was a nuisance. But if 1.25 billion people do that every day, well, then just look outside, that's what you have. So you have to change the behavior of repurposing waste. If we call it waste, it is waste. If it's not waste, it's reused, it's something different. So, as a former member of the National Task Force on Waste for the Confederation of Indian Industry, in fact, their steering committee, initial steering committee member, we recognize that India is unique in many, many ways. Waste is waste. It doesn't matter which city or which country that you are in. We call it a pollution or a waste because, as Buckminster Fuller, one of my gurus and one of the most brilliant minds, I think, of the 20th century, pollution is nothing but the resources we are not harvesting. We allow them to disperse because we've been ignorant of their value. Who here would agree with that? Would everybody here agree with that? So why are we calling it waste? We must call it resource. When I did the address in Mumbai last time I was here in November for the Confederation of Indian Industry Waste Summit, everybody talked about the same thing. It's now 6 months later, we're still calling it waste. We need to change the mindset. It's not waste, it's resources that we're repurposing. So we are basically a company that was formed in 2011 with a 30-year history. What I mean by that is that some of the technologies that we have started with the 1980s with contracts from the Environmental Protection Agency. They gave us about $4.5 million to study waste in different forms, especially toxic waste, heavy metals, etc. In 2011, we formed Bharco Ecotechnologies as part of the Bharco Group as a holding company for technologies and for the commercialization and the transfer of various proprietary technologies. We are going to talk today about centralized waste, and we're going to talk about decentralized waste. We're going to talk about centralized waste as a bridge technology to the ultimate future, which is decentralized. And I hope by the end of my presentation that you will agree with me that this is what we have to do. We have an immediate need for centralized solutions, and we must bring them to decentralized as fast as we can. It is much, much easier to deal with half a ton or 1 ton of waste than it is with 8,000 tons that the Municipal Commissioner of Mumbai was talking about. And that's projected to go up to 20,000 tons, 50,000 tons over the years. It is, to me, for lack of a better word, and forgive me, it's obscene. We need to bring it down to tangible things that we can do that are much, much better for Mother Earth and Mother India. So, look at these photos here. These are like the photos that were in the paper this morning. This is not India, by the way. This is Canada, one of the most cleanest, greenest countries of the world. They have the same problems with waste. As long as you say it goes in a dustbin and somebody else takes care of it, then you are having something called waste. So we have much less waste generation, but progress means, according to progress, we have much more waste, 6 times what the average Indian will produce. Now, I talked with the head of CII for Andhra Pradesh, an old friend of mine, a very, very good resource on waste management, one of the pioneers here in India. And he said to me when he bought his flat in Hyderabad many, many years ago, he had about this much, and he showed me, about this much waste every day. Now he has this much waste, he said, 2 bags full. Same household, same number of people, they didn't have any more babies, but it's consumerism, it's convenience, it's MTR packaging, it is, you know, and I love MTR, don't get me wrong, but it is, the kids today are looking at different things. Pizza. Anybody here have pizza once a month? Yeah, somebody does. Let's be honest, it's some people like it, some people don't. And so packaging is different. So what we talk about is habitats. We talk about true habitats, total resource utilization. A habitat can be a room. A habitat can be a ship. A habitat can be an apartment or a plant or an RWA. So we must define what our actual habitat is and do the total resource utilization of those habitats. We have also defined over about a decade and a half what is the ideal waste, centralized ideal waste treatment solution. So it is basically come down to 10 things. We call it our top 10 list. A closed system, not open to the air, water, or land. A system that will handle large volumes of waste economically. Economically is almost a synonym for sustainability. A system that can process a broad spectrum of waste. Why? There were 17 technologies brought to India over the last 15 years that have failed, that are working everywhere else in the world. Why does it not work in India? And there's reasons for that. But one of the most important reasons is understanding the very nature of waste in India is corrupted by industrial wastes, by biomedical wastes, and that's a fact. If you have a technology that is only good for municipal solid waste, it's not going to work. You need something that is robust and capable of having a broad spectrum of waste. Agreed? Yeah. So, no operator exposure. Occupational health and safety is paramount. At one time, people used to tell me that lives of India are expendable. If one person goes, the next person can come. Next person goes, next person. Forget about it. Everybody has got a worth. Everybody has got a place in this planet. And occupational health and safety is paramount. The days of slaves are gone. No odor. Who wants in my backyard odor? No toxic off-gases, no toxic ash, no uncertain storage of organic or toxic substances by landfilling or deep well injection, and no ocean or waterway dumping of waste. Would you agree that these are all important? So what we've done is looked at the ideal waste treatment plant from Bharco's perspective, and we said it's a totally enclosed plant. It has no chimneys, no emissions, no odors. It's an innovative, all-weather, permanent waste management solution. It was great yesterday to learn about the status quo. Today I'm going to talk to you about innovation, the future, which is available today. So this is what waste looks like here in India. This is something that we call water density gravity separation. And from this we produce a liquid RDF, a liquid refuse-derived fuel. We don't care about the moisture content because we're putting the waste in water. It's the oldest form of engineering arts. We end up with plastics floating, with glass, grit, sand, gravel going to the bottom, batteries to the bottom. When we go through everything, we end up with trommels, with eddy currents, with optical sorters, with blowers, all of these different things that end up becoming exactly what we need to end up with plastics over here and full separation and segregation. So, what's left now is our organics and waste in a swimming pool. Now this is where I become a chef, because every day I'm getting different feedstock. So I'm going to make a sambar out of this. Okay, the sambar one day is aloo sambar, next day it's drumstick sambar, next day it's carrot sambar. It doesn't matter what it is because I'm going to make a sambar. It's called liquid refuse-derived fuel. This liquid refuse-derived fuel is transportable by pipeline anywhere you want, just like you go to the sewer system. So you can take it and put these small transfer stations in small areas of the various wards, and you can actually transport the waste to a centralized factory with no hauling necessary. Now, this also eliminates landfill because everything is being repurposed. This is really what we're talking about. And we've just signed an MOU for a 1,000-ton per day plant.
The plant to convert a city's waste would fit in an industrial park in the host community. This plant has no smokestacks, chimneys, or flares. Everything is enclosed. The same trucks that collect the wastes from the community enter the separation building and drop the wastes into a shallow basin. The wastes are then lifted into a heavy-duty industrial washing machine. After washing, plastics and bottles float, are separated, and then recycled. Metal items, sand, grit, and glass sink, are separated and then recycled. Roughly chopped paper scraps, food scraps, yard wastes, wood scraps, farm wastes, and all their fibers remain in the water. These fibers are chopped and processed a second time. These fiber materials are then thickened and blended with organic sludges, septic and pulp wastes, and cooked down in a gravity pressure vessel. The wastes of the city do not have to leave the city. This plant is a major step to a zero waste community.
So what you're seeing in this animation is the closed version of the video that you saw before. So there are no emissions to the air, land, or water unless they're verified. We use something called a deep well chemical reactor. It's been done many, many times before. And basically the sambar goes into this deep well. It's enclosed with full safety. It is sealed from the strata. Oxygen is mixed into this sambar. And just like your pressure cooker on your stove, what happens? You get psst, 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 3 whistles, the rice is ready? Okay, well, this is the same concept, except we don't let that wasted energy go to the air. We capture that energy in a reaction zone, and as a heat exchange, and it produces something that is extremely energy efficient. 99.4% of the energy that is created within the system, because it's a closed loop, comes out. Now, we can talk about the mechanics of it later, but the best part of this is clean water, because on the very first slide I said the resource recovery imperative is energy and water, not in that order, water and energy. So we're producing clean water, and we actually have a desalination facility as part of this. The types of feedstock that we look at, again, we are waste agnostic. Any type of waste that a community produces, whether it's biomedical waste, municipal waste, whether it's hazardous waste, can be treated with this facility. The Army Corps of Engineers of the United States of America has said that this is the best thing for high-strength waste, including mustard gas. That's pretty hazardous stuff. So I want to move to centralized to decentralized technologies. And the decentralized technology, we look at, again, what is the energy resource in that waste. So if we can produce a 1 ton a day appliance, if you will, that can produce energy, more energy than it consumes, I think we've got a winning thing. And as Dr. Chowdhury said, it's not official till, well, it's official now, but I can tell you very proudly that what we're going to introduce today, called MAGS, Micro Auto Gasification System, has won the Green Tech Award globally. We'll be in Berlin on May 12th to accept the award at the gala. We're very, very proud of that, so thank you, thank you. So we have 2 appliances. One is called MAGS, one is called WET. The micro auto gasification system was invented by Dr. Peter Tsantrisos, my partner and the CEO of the Terragon division. Terragon is a Montreal-based company, and he is also an amazing, amazing man with 35 years of experience in waste and energy. Every ship of the U.S. Navy that is what do we call the aircraft carrier, the pride and joy of the U.S. Navy, has Peter's technology. It was a plasma technology. He decided that plasma technology is a Rolls-Royce technology. What India needs, much to the happiness of Honda motorcycles, is 2-wheelers. And so what we have found is a 2-wheeler technology for India that will work. This is version 8. Version 9 is already being worked on, and Management-Bharat has asked us to work on version 10 specifically so that we can have one of these on every corner in the future. So this is the paradigm shift that is happening in waste.
How's your relationship with your waste? Are you close? Do you take it for granted? Most of us do. We leave it at the curb for someone else to deal with. Out of sight, out of mind. But what if you don't have anywhere to ship your garbage? Then even a little garbage can become a big problem. The problem Dr. Peter Tsantrisos meant to solve when he founded Terragon Environmental.
We're trying to provide solutions for people who cannot export their waste by developing a sort of small appliance that allows anyone to treat their waste locally and benefit from whatever resources they can extract from that waste.
The small appliance is the MAGS unit. Granted, it's bigger than a dishwasher, but it is smaller than a landfill. And it can reduce waste to the volume of a fridge to the size of a toaster. And the resources hidden in that waste? A carefully controlled thermal process that converts all organic material to a bucket of char. Char that sequesters the majority of carbon and is an excellent fertilizer. And in creating this biochar, gases are released that become the main fuel source for the MAGS unit. This baby fuels itself. In one day, a single MAGS unit can treat the waste of a small community. Perfect not only for ships, but isolated communities, resorts, and even hospitals. And that's just the beginning.
Hopefully one day in the future every home will have its own little appliance that will convert its garbage to hot water and fertilizing char.
That would be good for all our gardens, our communities, and our planet.
So version 8 has a thermal energy output. Version 9 will have a thermal energy output. Version 10 will have a thermal energy output. Right now, that thermal energy is being utilized for hot water. That's about 5% to 10% of India's needs in terms of municipal people that can actually use hot water right now. Version 9 will be about 40% to 50%, maybe even 60%, because it will have an interface to create cooling, refrigeration, cold storage. So that at every village, for example, you could have one of these to create cold storage for the produce that is being produced by the farmers so they don't spoil. Make sense? Yeah, the Ministry of Renewable Energy thinks it makes a lot of sense, and so does the Ministry of Science and Technology. This is thinking in the future with something that is here. Version 10 will be standalone, so that you don't have to have any electricity to plug it in, and you can actually have it on the back of a truck. Imagine if the municipal worker, rather than putting it into a trolley or a three-wheeler, actually put it into a final disposal. This is what the final disposal is, and this is how it works.
Tarragon Environmental Technologies introduces its patented micro-auto gasification system, MAGS, the world's most compact and environmentally friendly waste treatment appliance. MAGS is a fully automated waste processing system which converts mixed waste, such as plastics, paper, and food, at the site where it is generated, into thermal energy and a solid carbon matter called biochar. MAGS eliminates the environmental impact of waste transportation, landfilling, and incineration. Here's how it works. When a bag of waste is loaded in MAGS, it drops into the gasifier, a heated gasification chamber. In the gasifier, high temperatures break down the waste and transform it into
incineration
biochar
here.
and a gaseous fuel called syngas. The biochar accumulates at the bottom of the gasifier, while the syngas travels into the combustion chamber, where it is ignited. The hot gas produced by combustion heats the gasifier. In this way, syngas produced from the waste becomes the main fuel source for MAGS. The gas is then instantly cooled with water before passing through the system's scrubber, where it is cleansed of any pollutants. The remaining emissions are invisible, odorless, safe, and meet the most stringent environmental regulations worldwide. Additionally, the process recovers thermal energy in the form of hot water, which can be reused by the site. MAGS is a practical appliance for those who choose to treat their waste locally and economically while benefiting from the recovery of valuable resources.
It's a very small appliance. It's about 2 meters by 2 meters by 2.5 meters. It takes about 150 square feet, including operational room. You'd put about 50 kg per hour as the throughput. It can work 24 hours a day. It's fully automated, and it is so. One of the most difficult things in MAGS, I think, is very, very, very difficult to load it. I'm going to show you how difficult it is to load. Oops. I think you need to have, Dr. Chowdhury, I think you need a PhD from your school to load this. Very difficult. It's about 75 dB operating. It's very difficult to open the door, take the bag, put it inside, totally safe to put your hand inside, close the door, pull the latch. That's how difficult it is. So it is very, very emissions friendly. Look at dioxins, the line for dioxins and furans. This is third party. This is why the International Maritime Organization, with their MARPOL rules, which are 10 times more stringent than anything on the land, have even now putting a new classification for pollution and for energy appliances. This is something, because if you're on a ship, like a medical destroyer, a Navy destroyer, you have medical waste, pharmaceutical waste, biomedical, hazardous waste, municipal solid waste, you got everything. You need to be able to handle it, and you need to be able to handle it in a way that's responsible for the environment as well. I'm going to take about 4 more minutes, Dr. Chowdhury, and then we're going to be finished, and we have 2 speakers here. The char removal is also very, very easy. We can talk about it. Biochar, this is what it does. Look at the photo on the bottom. You'll see that a control fern has root development. This was done in Hawaii, by the way, in 2005. Fertilizer, the NPK is good, manure is good, compost is good, but when you put biochar in, as Dr. Lal said to me yesterday in the foyer, it's like putting something on steroids almost. It's really, really amazing. It's like the principle of crop residue burning, which has been done for years, but unfortunately, we can't do that anymore. We have other solutions for that as well. This is the integrated solid waste management of the future. In every building, in every habitat, everywhere. We do believe in composting. We do believe in recycling. But what we also believe in is making sure that soiled plastics, soiled paper, and everything else that cannot be recycled or should not be composted. Cooked food should not be composted. It should be raw vegetables, raw fruits, things that are not cooked. That gives you the best quality compost. You mix that best quality compost with biochar, you've got an amazing fertilizer because the carbon is now back into the soil. And this is some of the installations that we've done in land, on sea, everywhere, 135 installations. Tell me, does this look like a waste management plant? This is capable of India. This is available, we're starting to ship these in the 3rd quarter of 2017. What year is it? 2000, how time flies. And this is some of the marine applications, remote community applications, military and defense enterprises, industries. Everything from e-waste, and there's an e-waste solution here. If NGOs are interested in that, please come and talk to me about that. There is for hazardous waste, even Axo Dyno Nobel has explosives, Nobel, TNT. They were spending $2,000 a ton to get rid of their waste. Now they don't have to worry about it. Waste is repurposed. So I'm going to finish with this, and we're done. This is not from us, this is from the U.S. Office of Naval Research.
Imagine a system that takes 100 pounds of trash and turns it into 5 pounds of harmless ash and creates more energy than it uses. Well, ONR's science advisor, Don Murakami at Camp Smith Marine Base in Hawaii, has been testing a system that does just that. It's called the Micro Auto Gasification System, or MAGS. The MAGS reduces solid waste by as much as 95%.
It's non-toxic, something that you can use for mulching, plant vegetables or fruits. The bottom line is you're reducing that volume of trash down.
Because the waste is not incinerated, it dramatically reduces the carbon dioxide produced by the processing. Additionally, gases created by
from alternative sources.
In order to gather input on the feasibility of using MAGS for forward operating bases, the Marines evaluated MAGS during a recent test.
Waste disposal in the field is a huge problem. It has the space requirement, it has the health requirements that everybody has. Additionally, we have a security requirement, and that anything that we throw away, we have to make sure it can't be used back against us, or that nobody gets hurt scavenging through it.
This new process could also benefit many outside of the military.
A lot of things we do in the military can have huge benefits for things in the commercial world. For example, What we're looking at forward operating bases could easily be applied to a school, a hospital, an office building, disposing of our waste in a different manner than just sending it to the landfill. Really, it is because of ONR that we have this project here and we have made progress in this area. I think the best thing about MAGS is that it's brand new technology, but widely applicable. It hits on things like the environment and sustainability, and it's really opened people's eyes into how we could attack this problem differently. Really, the heart of the technology for MAGS is gasification. And the new thing with MAGS is that we're able to do it on a much smaller scale than it has occurred in the past. So really, it's about miniaturizing that technology and making it small enough that we could even think about deploying it into the field. Well, the beauty of MAGS is that we're using our trash as a source of fuel. So even though we use electricity to power MAGS, the energy output of MAGS is more than what we put into it. And so there's an opportunity to use that heat that comes out of it to do something productive with.
And I thank you for your time this morning. That's the end of my presentation.